All right, 8.8, distance in a plane. We already learned back in 8.6 about the Pythagorean theorem, which tells us that for any right triangle, a squared plus b squared, the legs, equals c squared, right? This is for a right triangle. Two legs, distance squared, sum of the distances squared equals the hypotenuse squared. All right, and we should already know about distance on a line. All right, distance on a line. Right, very simple. You've got your first point and second point. You will usually see these referred to as x2 minus x1, absolute value thereof. That is distance on a line. Knowing those two things, we can use the coordinate grid. Right? So let's call this the origin, 0, 0. We can pick any 2 points on this coordinate grid and figure out a distance between them. Because, for instance, I'm going to go with this right here, right? This would be 2, 1. We'll stick in quadrant 1 for this example. And I'm going to throw one up over here. This would be 6, 4. Well, when you're doing any line between 2 points in a plane, what you actually have is a difference in x's and a difference in y's, right? There's a horizontal difference and a vertical difference. And, well, what is this? This is a right triangle because the x-axis and the y-axis are perpendicular to each other. So I know that the difference of the x's is 6 minus 2. It's from 6 to 2. 6 to 2 gives me 4. I know the difference in my y's is 3. 4 minus 1 is 3. Now, how do I use the Pythagorean theorem here? Well, my x's difference, my y's difference, those are the two legs of the right triangle, and the distance between the 2 points, straight line distance, is my hypotenuse. So if I take my 4 squared and add my 3 squared, that should be hypotenuse squared. Now in this case, probably by instinct, I have chosen the perfect square. So 4 squared is 16, 3 squared is 9. That's 25. That's a terrible looking 25. That's marginally better. That's the hypotenuse squared, and of course the square root of 25 is 5.